Hello guys, it's Angels here, and today we'll be reading Smokescreen, Gas Mask, Chemistry Goes to War. Now, with that out of the way, let's get into it. Smokescreens and Gas Masks, Chemistry Goes to War, by Tim Ripley. Chemistry at War. During World War I, German commanders wanted to capture a French fortress at Verdun, the France's eastern border on February 21, 1916. German artillery opened fire. Just under 5 hours, 800 big guns fired around 1 million shells at French positions. The French defeated the fort for 9 more months. The fort of Germans withdrew to the bomber this ever fired. And it showed the importance of chemistry in warfare. Chemists has not only developed explosives for the shells, they have also figured out ways to make millions of shells quickly and relatively safe. British workers make shells in a factory during World War I. Weapons development. Chemistry is the science of the substances that make up all matter. Chemists examine how substances react to forces. They also combine substances to make new ones. Chemistry has shaped weapons since ancient times. Ancient peoples learned how to make metal blades and points for weapons. Next came the discovery of gunpowder in ancient China. When gunpowder reached Europe in the 13th century, it transformed warfare. Gunpowder allowed for development of weapons such as cannons, pistols, and muskets. In the 18th and 19th centuries, chemists developed new explosives and ammunition. They came up with weapons such as poison gas and incendiary weapons that cause fires. Chemists have also created new materials to protect soldiers in battle. In the 21st century, chemistry remains at the heart of warfare. A soldier fires a replica of a World War I flamethrower. The weapon uses high pressure to shoot a jet of liquid fuel that is set on fire. The first flamethrowers were used in the 7th century. Now that's old. Swords and blades. One of the first uses of chemistry in warfare was to make bladed weapons. The process depended on being able to heat and shape metals. The earliest weapons were made from stone or flint. In the 4th millennium BCE, people learned to forge bronze. They used a new metal to make sharper blades for weapons. The stronger bronze blades and arrowheads gave armies an advantage, since ancient people such as Egyptians supplied their armies with bronze swords and axes, as well as spears and arrows. Bronze was quite soft, however. Over time, bronze blades bent or grew dull. In about 1300 BCE, people learned to achieve very high temperatures in furnaces. That allowed them to extract iron from iron ore. Early chemists learned to melt metals at very high temperatures. Liquid metals can be poured into molds. A U.S. fits his bayonets into his weapon. Steel bayonets are still used for hand-to-hand fighting. This development marked at the start of the Iron Age. People soon began to use iron to make weapons. Iron and steel. Iron made bronze absolute. Bronze weapons could not pierce iron armor. In turn, iron was replaced by steel by around the 300s BCE. Steel was even stronger and lighter than iron. It also kept its sharp edge for longer. In the modern era, infantry soldiers still attach steel bayonets to their rifles. Bayonets are used as stabbing weapons in close combat. Science file. Metallurgy and metals. Bronze is an alloy, a metal made by mixing two or more metals. Bronze is made by mixing copper. Tin. Metallurgy is a science to combine metals to make alloys. Early chemists learned to use heat to create new metals. New alloys were stronger, lighter, easier to make into weapons than pure metals have been. Fire as a weapon. Since prehistoric times, fire has been an important weapon. Early chemists learned to direct fire against targets. Ancient armies used fire as a destructive weapon. Many early battles were sieges. In a siege, an army surrounded by a walled city to force it to surrender. Fire could help burn wooden city walls, create gas for soldiers to enter the city. Burning missiles were also thrown to besieged towns. The missiles set fire to buildings that terrified people inside the town. Wooden defenses and buildings burned easily. Medieval buildings stood close together, so fire spreads quickly. Fire and water. The first necessary weapons were burning bales of hay or grass. They were fired with catapults and bows at sea. Necessary weapons were used to set fire to enemy warships. Ships would sink or be put out of action. Sailors filled old ships with fuel. They set the fuel on fire and pushed the fire ships toward enemy ships. Early necessary weapons could easily be put out with water, and they cannot be used in the rain. They're also difficult and dangerous to move and use. French rafts full of burning materials float toward ships in the British Navy in 1759. France and Britain were fighting over control of the French colony in Canada. Science file. Greek fire. Greek fire was a flammable gel that could be molded into bowls and fired. Its exact composition is unknown. It was invented during the Britton Empire. The Britons fought their Mycenaean neighbors from the 7th to the 13th centuries. They fired the weapons from catapults or attached it to arrows and fight off their attackers. Greek fire. 7th century, early necessary metals were replaced by Greek fire. This was a sticky, flammable material. It burned even on the surface of water. That made it useful for naval and siege warfare. This weapon, called a trebuchet, used a long lever to throw barrels of Greek fire toward the enemy. Sailors used Greek fire to make burning missiles. They threw the missiles catapults on the decks of ships, helped them to bombard enemy safe distance. Greek fire was used in weapons such as cannons. These weapons often burned down wooden orphanages and sieges. Then engineers began to build city walls out of stone, and they replaced the straw roofs of castles with tiled roofs. Tiled roofs were far more difficult to set on fire. This illustration from the 12th century shows Byzantine sailors using a flamethrower against an enemy vessel. Science file. The first flamethrowers. Byzantine warships carried the world's first flamethrowers. A single pump was fitted to the front of a ship. Sailors pumped to build up pressure, and they used the pressure to shoot a devastating stream of Greek fire. The first explosives. In the 13th century, Europeans heard stories about magical potions in China. Those said that the potion explosions. Gunpowder was probably invented in China sometime in the 9th century. Experts think that Chinese scientists wanted to set targets, such as enemy buildings, on fire. They're trying to create an incinerator weapon like Greek fire. Scientists probably mix two chemicals called saltpeter. The mixture did not just burn, it exploded. The early this probably did more experiments. They figured out the right amount of sulfur and saltpeter, use the biggest explosion to get the biggest explosion. Mixture with gunpowder. Chinese archers special baskets to launch burning arrows into illustration from the 11th century. Each launcher could fire multiple arrows. The first rocket. Gunpowder weapons evolved quickly. The next step was the creation of first rockets. They assembled large exploding arrows or modern fireworks. Chinese scientists figured out how to make the first cannons. They realized that an explosion in a small space would cause a rapid burst of gas. If that gas was contained, it could push a projectile along a barrel at high speed. Chinese soldier uses a burning stick to set light into an exploding rocket. The first gunpowder weapons were like modern fireworks. Science file. Chinese gunpowder. Chinese gunpowder was a mixture of sulfur and saltpeter. It was the only explosive if the right quantities were used. Gunpowder was also called black powder of its color. It changed warfare completely. Gunpowder led to the development of exploding missiles, but also led to weapons that could fire bullets or shells over. Speed was high enough the projectile could keep traveling forward after it had left the barrel, and the gas had disappeared. This is the concept between operation of oak cannon. The earliest Chinese cannons were small. Later cannons was much bigger. They could fire projectiles hundreds of yards. The first cannon barrels were made from wood. They sometimes split because of the huge wood inside. Wooden barrels were soon replaced by barrels made from cast metal. The first cannonballs were made of metal or stone. Metal that was filled explosives, so the ball was shattered on impact. Damage over a greater area. Early cannons defended the Great Wall of China. China's rulers built a long wall to protect their empire. Peoples who lived to many battles in China were sieges of castles or cities. Gunpowder weapons made it far more difficult to build defenses against. First firearms. Chinese scientists next developed the first firearms. These were the first gunpowder weapons to be used by individuals. They were long-barreled guns that were carried and fired by individual soldiers. Guns were clumsy, also unreliable. Often the soldier missed the target or the gun failed to fire. However, these first firearms pointed the way for future weapons in Europe. Science file. Explosives and castles. Gunpowder transformed sage warfare in China. Attackers used catapults or rockets to fire bombs at fortresses, walls, castles, or cities. No longer be easily defended. Explosives can knock walls and high new fortresses were built was filled with rock and soil. These materials absorb explosions without collapse. Gunpowder in Europe. Gunpowder reached Europe in the middle of the 13th century. Chemists figured out ways to make the new invention. Engineers came up with new weapons to use it. Chemists made gunpowder from sulfur, charcoal, and potassium or saltpeter. First gunpowder weapons used a spark to ignite the gunpowder. The gunpowder created an explosive flash and a shockwave to anything nearby. It also set fire to flames. Engineers realized that gunpowder in a tight space fire a missile. They began making cannons, pistols, and muskets. An illustration from 1326 shows a European soldier using the fuse of an early cannon. The cannon is loaded with an arrow-like missile. Weapons fired shells, bullets, or rockets. By the 15th century, an army in Europe used gunpowder weapons. Vital materials. The ingredients of gunpowder became vital items for armies. Countries such as Britain and France had large empires. They could get the materials from overseas that helped them manufacture more gunpowder. Countries also wanted to make metal cannons and guns. This need to make weapons helped start at the Industrial Revolution. This was the period of industrial change that began in the mid 1700s. Modern battle reckoneers fire a light cannon. In the 1700s, armies began to using light cannons that were easy to move and could be fired by a small gun crew. The brains. Reference SWAT words. Not SWAT wars. The 1300s. It's thought to have a German chemist. He's also known as Bernhard Black because he worked with gunpowder. In the middle of the 14th century, Berthold is said to have invented the form of gunpowder. Some experts call him the father of European gunpowder. Others think that he may not have existed. Smokeless powder. Gunpowder caused a problem on the battlefield. It produced thick clouds of smoke, making it impossible for command to see what's happening. The first gunpowder, small arms, were arquebuses. Oh, these were sometimes called muskets. They were loaded by tipping gunpowder and bullets into the end of the barrel. The weapon was fired with a burning fuse that set off the gunpowder. By the late 19th century, muzzle-loaded muskets have been replaced by breech loaders. And these bullets were loaded at the back of the barrel with a percussion cap behind. Smoke rises as modern battlefield detonated fighter muskets in the early 1800s. The thick smoke hung in the air and burned the eye and nose. When the trigger was pulled, the hammer struck the bullet. This set off the smokeless powder powder in the percussion cup. Explosive bullets. Breech loaders use new smokeless explosives developed by chemists in Europe and North America. These explosives were more powerful than gunpowder. For the first time, bullets or artillery missiles could be combined with explosive. The warhead and the propellant were in a single metal container. This was a modern bullet or shell. The firing pin of a rifle struck the sparking cap behind the bullet. This development, weapons could be safely transported and stored. The mass production of ammunition became possible. Modern rifle shells include a percussion cap at the back, explosive powder in the bullet itself at the tip. Well, and that was today's video. Hope you guys enjoyed, and I'll see you guys again very, very soon. Later.